In this lecture of S2 Business Mathematics for CA and Corporation, we are focusing on the problems of quadratic equation. So the first question we are going to discuss is about the nature of the roots of the quadratic equation. So we are asked to find the nature of the roots of the quadratic equation. So nature of the roots of the quadratic equation, and the equation is 8x square minus 2x minus 4 is equal to 0. So according to the general form, of quadratic equation, ax square plus bx plus c equals 0. So where a is equal to 8, b is equal to minus 2 and c is equal to minus 4. So in order to find the nature of the root, roots of the equation, we need to find what is b square minus 4ac and see whether it is greater than 0 or equal to 0 or less than 0. B square minus 4ac is greater than 0 or equal to 0 or less than 0. So let's find what is b square minus 4ac. So b square minus 4ac is equal to minus 2 the whole square minus 4 into 8 into minus 4, which is nothing but 4 plus 16 into 8. That is 4 plus 128. That is 132. So which is greater than 0 and it's not a perfect square. So since it's not a perfect square, the roots are irrational and unequal. So when we are asked to find the nature of the roots of the equation, we need to see whether b square minus 4ac is greater than 0, equal to 0 or less than 0. If it is greater than 0 and it is a perfect square, it is a rational number and unequal. But if it is a not perfect square, it is a irrational and unequal. So moving on to the next question. If the roots of 2x square minus 2x plus 3 equal to 0. So you are given a quadratic equation, that is 2x square minus 6x plus 3 equals 0. So according to the general form, ax square plus bx plus c equals 0. A is equal to 2, b is equal to minus 6 and c is equal to 3. Okay, now we are asked to find the sum of the roots. So the formula for finding the sum of the roots is minus b by a, and product of roots is c by a. So minus b by a means it is 6 by 2, that is 3, and c by a is 3 by 2. So product of roots is 3 by 2 and the sum of roots is 3. So the roots are alpha and beta. Find the equation with the roots 1 by alpha and 1 by beta. So the formulation of quadratic equation is of the roots 1 by alpha and 1 by beta. So that is x square plus H square minus sum of roots into x plus product of roots equals 0. So here the roots are given as 1 by alpha and 1 by beta. So x square minus 1 by alpha plus 1 by beta into x plus 1 by alpha into 1 by beta equals 0. So this can be rewritten as x square minus beta plus alpha by alpha beta into x plus 1 by alpha beta equals 0. So from the above equation we got alpha plus beta as 3 and alpha into beta as 3 by 2. So substituting these values over here, so it is x square minus 3 by 3 by 2 into x plus 1 by 3 by 2 equals 0, which is nothing but x square minus 2x plus 2 by 3 equals 0. So this can be rewritten as x square 3x square minus 6x plus 2 equals 0. So this is the required quadratic equation for the roots 1 by alpha and 1 by beta. So 3x square minus 6 plus 2 equals 0. At first you have to rewrite the quadratic equation. Find a, b and c. So according to the general rule, the sum of the roots can be found by the formula b by a, and the product of roots found by the formula c by a. So the formation of the quadratic equation with the roots according to 1 by alpha and 1 by beta, the general form is x square minus sum of root into x plus product of roots equals 0. So substituting 1 by alpha plus 1 by beta into x plus 1 by alpha into 1 by beta 0. So we substituting alpha plus beta as 3 and product of alpha and beta as 3 by 2, and thus we got the equation 3x square minus 6x plus 2 equals 0. So the next question is solve 2 by x plus 2 by x plus x by 2 equals 0 equals 2. 2 by x plus x by 2 equals 2 is the question. So what we have to do is we have to cross multiply these two. So that is 4 plus x square by 2x equals 2. So we can rewrite the equation as 4 plus x square equals 4x. So which implies x square minus 4x plus 4 equal to 0. So which is at the form a minus b the whole square, that is a square minus 2ab plus b square. So the general form is x minus 2 the whole square equals 0, which means x minus 2 equals 0. So x is equal to 2. For the next question, we are asked to solve x plus 3 into x plus 6 plus x plus 6 into x plus 9 plus x plus 9 into x plus 3 equals 0. So what we are going to do is we are going to group each of them. So this is one group, this is second group, and this is third group. So the first group is x plus 3 into x plus 6. X plus 3 into x plus 6. X plus 3 into x plus 6. So, which is of the form x plus a into x plus b is equal to x square plus a plus b into x plus ab. So, x square plus 9x plus 18. So, the next group is x plus 6 into x plus 9. That is x square plus 15x plus 54. The next group is x plus 9 into x plus 3, which is x square plus 12x plus 27. So adding all this 1, 2 and 3, equation will be x square plus 9x plus 18 plus x square plus 15x plus 54 plus x square plus 12x plus 27 equals 0. So how many x square? We have 3x square plus, when you add 9x and 15x and 12x, it is 36x plus 18 and 54 and 27, and together we get 99. So dividing by 3, divide by 3, we get the expression as x square plus 12x plus 33 equals 0. So, by applying quadratic equation, a is equal to 1, b is equal to 12 and c is equal to 33. So, minus b plus or minus root of b square minus 4ac by 2a. So that is minus 12 plus or minus root of 12 square is 144 minus 4 into 1 into 33, which divided by 2, that is minus 12 plus or minus root of 12 by 2. When you cut short, we will get it as minus 6 plus or minus root of 3 by 3. So minus 6 plus or minus root of 3. Minus 6 plus or minus root 3 is the answer. So the value of x can be either minus 6 plus root 3 or x is equal to minus 6 minus root 3. So moving on to the next question. So in example 10, we are asked to find the sum of the squares of two consecutive odd numbers is 74. Find the numbers. So let the number be x, and the consecutive odd number means it is x plus 2. Okay, let the number be x and x plus 2. So the sum of squares, so x square plus x plus 2 the whole square is equal to 74. So x square plus x square plus 4x plus 4 equals 74. So 2x square plus 4x minus 70 equals 0. So you can divide the whole equation by 2. So we'll get as x square plus 2x minus 35 equals 0. So according to the general form, A is equal to 1, B is equal to 2 and C equals minus 35. So the product AC is equal to minus 35 and the sum should be 2. So it can be 7 and this is minus 5. So x plus 7 x square. So this can be written as x square plus 7x minus 5x minus 35 equals 0. So x, taking common, x plus 7 minus 5 x plus 7 equals 0. So x minus 5 and x plus 7 equals 0. So x can be either 5 or minus 7. This can be 5 or minus 7. Now, moving on to the next example, that is example number 11. So, divide 50 into 2 equal parts so that the sum of the reciprocal is 1 by 12. So, we have a 50, so we will divide the 50 into 2 parts. So, one is x and other is 50 minus x. So, 50 is divided in 2 parts, one is x and 50 minus x. So, the next part is sum of the reciprocals is 1 by 12. So, 1 by x plus 1 by 50 minus x is equal to 1 by 12. So, what you have to do is, you have to cross multiply. So, 50 minus x plus x by x into 50 minus x is equal to 1 by 12. So this is nothing but 50 by x into 50 minus x is equal to 1 by 12. So cross multiplying, so we get as x into 50 minus x is equal to 600. So 50x minus x square equals 600. So minus x square plus 50x minus 600 equals 0. So taking minus inside, so x square minus 50x plus 600 equals 0. By using this, we need to find the roots. Okay, so a is equal to 1, b is equal to minus 50 and c is equal to 600. So AC, the product is 600 and the sum is minus 50. So it is minus 30 and minus 20. So x square minus 30x minus 20x plus 600 equals 0. That is x square, taking x outside, so it is x minus 30 minus 20 out, so x minus 30 is equal to 0. So x minus 20 and x minus 30 equals 0. So x is equal to either 20 or 30. Now, this is a very important question. You have to be very careful when you solve this question. So, at a certain meeting, so there was a meeting. So, 11 times the number of members is greater by 12 than twice the square of the number. Find the number of the members. So, let x be the number of members. Let x be number of members. If that is the case, 11 times the number of members means it is 11x. 11 times the number of members is 11x greater by 12 than twice the square of the number. Means 11x minus 12 is equal to twice the square of the number. So 11x minus 12 is equal to 2x, or you can consider 2x square plus 12 is equal to 11x. Neither way you can consider. So let x be the number of members. If so, 11x minus 12 is equal to twice the square of the number, 2x square. Or you can say twice the square of the number plus 12 is equal to 11x. So solving the quadratic equation, we'll get so I am considering this one. So I am going to consider that one. So our equation is minus 2x square plus 11x minus 12 is equal to 0. So 2x square minus 11x plus 12 equals 0. So according to the general form of the quadratic equation, a is equal to 2, b is equal to minus 11 and c is equal to 12. So AC is equal to 24 and the product is minus 11. So it is minus 6 and minus 4. It is minus 8. It is minus 8 and minus 3. So the product is 24 and the sum is minus 11. So it is minus 8 and minus 3. So 2x square minus 8x minus 3x plus 12 equals 0. So taking 2x out, x minus 4 minus 3 out, x minus 4 equals 0. So it is 2x minus 3 and x minus 4 equals 0. So here the number of members x will be 4. We will take only a positive number because we are asked to find the number of members. So the member will not be a fraction, it will only be a positive number. So we consider x is equal to 4. Now moving on to the next question. You are asked to find the quadratic equation with the roots 1 by 2 and 1 by 3. So we are given the roots and we are asked to find the quadratic equation for this particular root. So the general formation of the quadratic equation is in the form x square minus sum of roots into x plus product of roots. is equal to 0. So x square minus sum of root is 1 by 2 plus 1 by 3 into x plus product of root is 1 by 2 into 1 by 3 is equal to 0. So x square minus, we can write 3 plus 2, 3 plus 2 by 6 x plus 1 by 6 is equal to 0. That is nothing but 6x square minus 5x plus 1 equals 0. So this is the quadratic equation. Whenever the roots are given, what we have to do is substitute in a general formation of the quadratic equation is x square minus sum of roots into x plus product of roots. So substituting the value of the roots 1 by 2 plus 1 by 3 into x plus 1 by 2 into 1 by 3 equals 0. So x square minus 5 by 6 x plus 1 by 6 is equal to 0. This is x square minus 5 by 6x plus 1 by 6. Taking 6 LCM, the equation will be 6x square minus 5x plus 1 equal to 0. So moving on to the last question. You are asked to find the positive value of k if 1 root of x square minus kx plus 243 equals 0 is thrice the other. So you are given the quadratic equation x square minus kx plus 243 equals 0. This is the quadratic equation, and you are asked to find the positive value of k. One root is alpha, then the other root is 3 alpha. Okay, so we are asked to find what is the sum of the roots. So we have the product of root. Product of root is alpha into 3 alpha. So that is 3 alpha square. So according to equation, we are given a is equal to 1, b is equal to minus k, and c is equal to 243. So the product of roots is 3 alpha square is equal to 243. So 3 alpha square is 243. So alpha square is equal to 81. So implies alpha is equal to 9. Alpha is equal to 9. So sum of the root will be, sum of the roots is alpha, sum of the roots will be alpha plus 3 alpha. So one is 9, the other one is 3 into 9, that is 27. So the value is 36. So k is equal to 36. So we are asked to find the positive value of k if one of the roots is thrice the other. So first root is alpha and the other one is 3 alpha. So from the product of root formula, we substitute over there in order to get the value of alpha. So we got the value of alpha as 9. Alpha is 9. So the sum of the roots is alpha plus 3 alpha, that is 36. So substituting it over the k, we will get 36. So the value of k is 36. Hope it is clear for you. In the next session, we will be dealing with the
polynomials.